AI becomes so confusing when we focus too much on the outputs. Those are the essays, the artwork, the code, even the conversations. But the real secret behind generative AI isn't in the results, it's in the mechanism that produces them. So in this video, we are going to break generative AI down into simple, understandable building blocks. At its core, generative AI is just a system that learns patterns from massive amounts of data and then uses those patterns to create new things. So it can create new text, new summaries, new instructions, new images, new solutions, even new conversations. Now, to make all of this easy to follow, we will bring back our smart warehouse robot from the last video. But this time, instead of only seeing the warehouse, listening to commands, or navigating efficiently, the robot will learn how to generate new text, rewrite instructions, and produce summaries, and even invent new solutions based on everything it has learned so far. And by the end of this breakdown, you will understand exactly what powers modern generative AI and why it represents such a massive shift in how machines can think, reason, and create. So let's start with the foundation, deep learning. So deep learning is a special branch of machine learning that uses layered neural networks. These are structured, inspired loosely by neurons in the human brain, to learn from extremely large amounts of raw data. The more data a network sees, the better it becomes at recognizing not just simple patterns, but deeply complex relationships across text, images, audio, and code. So I would like you to imagine our warehouse robot reviewing millions of past instructions, camera snapshots, routine decisions, and scheduling histories. Over time, it begins to recognize how humans describe packages, how tasks are usually assigned, how routes are efficiently planned, and how instructions typically flow. This pattern recognition is the core ingredient that makes generative AI possible. Now that our robot can recognize patterns, the next question is simple. How does it use those patterns to create something new? Generative AI refers to systems that create new content based on patterns they've learned from enormous datasets. And this content can take the form of text, images, audio, music, video, even computer code. Modern tools like ChatGPT, Claude, Gemini, or even Midjourney are all forms of generative AI. So they use deep learning to understand statistical patterns in data and produce new outputs that feel natural, coherent, and meaningful. So instead of simply following instructions, our warehouse robot can now create its own reports, generate detailed step-by-step plans, draft safety guidelines, rewrite confusing instructions, and propose new workflow improvements. So it produces new ideas based entirely on what it has learned from the past information. To understand how it does this in detail, we need to look at the specific models behind modern generative systems, and that's the large language models. So a large language model is trained on enormous data sets, often billions or trillions of words spanning text, images, audio, video, sometimes programming code, right? So the model learns patterns, structures, and associations by analyzing these examples. So before a model can understand any text, it breaks the input into smaller pieces called tokens. And these tokens help the model understand language at a fine-grained level because they represent meaningful units. So these are complete words, subwords, or even punctuation. So when the robot reads the sentence, handle this package with priority, it doesn't interpret it as one block of text. Instead, it breaks down the sentence into smaller parts, analyzes each token, and then predicts what token should logically come next based on everything it has learned. Through a mixture of supervised and unsupervised learning, the model learns which tokens frequently appear together, which ones tend to follow certain patterns, and what makes a sequence sound coherent and meaningful. Tokenization is the first step, but the real breakthrough in modern generative AI came from a new architecture, transformers. Transformer is a neural network architecture designed specifically to understand relationships between different parts of a sequence, such as the words in a sentence. So what makes transformers so powerful is the attention mechanism, which allows the model to examine all the words in a sentence at the same time. Now, this lets the model understand context in a way that traditional neural networks could not. For example, in the instruction, place the fragile box on the top shelf, the model uses attention to understand that fragile describes the box and not the shelf. So instead of reading instructions word by word in a fixed order, our robot will use the entire sentence at once. So it identifies which words relate to each other and which parts of the instructions matter most, and what actions should come next. Once trained, large language models use these relationships to generate new content by predicting the most likely next token, and the next one, and the one after that, until the complete response is formed. Now that we understand how generative AI works internally, let's explore what it can actually do. So generative AI can create content. It can be used to produce new text, images, audio, video, and code. And for our warehouse robot, it means generating daily summaries, optimizing instructions, safety reports, and updating guidelines. Secondly, generative AI can personalize. So it can adapt to different users by producing personalized messages, tailored recommendations, and customized communication based on context and behavior. Next, generative AI can extract and analyze. So it can summarize long documents, extract key insights, clean up messy data, and help with analysis. So it transforms unstructured information into something useful and digestible. Next, it can generate code. So generative AI helps developers by developing code or generating code and code snippets, test cases, and automate scripts. So this dramatically speeds up development and reduces repetitive tasks. Next, it can match. So generative AI can match applicants to jobs, users to products, or customers to services by recognizing patterns and attributes and behavior. And finally, it can transcribe and translate. So generative AI powers speech recognition, language translation, and multilingual communication, which enables seamless interactions across languages and environments. Now, all of these abilities become even more powerful when generative AI is integrated into an autonomous system. So an AI agent is a system capable of operating independently. So it can observe its environment, make decisions, take actions, and pursue goals without constant human supervision. So generative AI becomes the thinking tool inside the agent. So it interprets instructions, analyzes information, generates plans, adapts to new situations, and coordinates actions. So this combination allows the agent to operate with surprising autonomy. These agents already power virtual assistants, customer service chatbots, workflow automations, and autonomous vehicles. So generative AI is the brain enabling these systems to act with clarity and creativity. So generative AI isn't just one technology. It's a system built from a few core ideas. So deep learning for recognizing patterns, tokenization for breaking information into meaningful pieces, transformers and attention mechanisms for understanding relationships, and prediction for generating new content. Together, these principles allow our warehouse robot and every AI system to write, summarize, plan, translate, and personalize with remarkable accuracy. And all of this depends on one key type of generative architecture: the large language models, the engines behind tools like ChatGPT and Gemini. And they are the reason generative AI feels so powerful and so human-like. So if you want to understand the true heart of generative AI, in the next video, we are going to break down exactly how LLMs work. So tap here to watch the full breakdown of large language models. And I will see you in the next video.